Well, now we get to a curvy curve. Okay, everything we've done up to this point has been a lot of straight lines. Very straight line, horizontal line, straight lines, not a straight line. So this one's not going to be exact, it's going to be an estimate. We will later have a skill set to figure out this exact area if we know the formula for it, or know the function that it represents. But in the meantime, what we're going to do is read the problem. A large inflatable balloon of a cartoon character is being inflated before a parade. The rate of change of the volume of the balloon measured in cubic feet per minute is given by the graph below. Stop right there, label whatever you want to label. Okay, cubic feet per minute. This is a measurement of the flow of air measured in volume. So this is cubic feet per minute, and that means this is minutes. And same concept, if you find this area, you have found cubic feet. All right, let's keep moving. Estimate the number of cubic feet, that's what we're going to be doing, of air that was pumped into the balloon in the first 50 minutes of this process. Notice it said estimate, don't tell me exactly. We won't have a way of knowing. We really won't. So I have an excellent idea. How about we get off topic for just a second? My original draft of these notes, I was coming up with an idea for this and like, let's inflate a balloon. Let's make it like one of those parade balloons. And then I Googled ugly cartoon character balloons, and I originally had this on the notes. It looks, I have no idea what this is, but it looks like it's eating those people on the street. It's just terrifying. Okay, back on topic. I don't remember exactly how I worded my Google search, but that was one of them. So I want to estimate this area right here, and I have an idea that involves a ruler. Why don't we just connect some points, and you'll kind of see, I'm looking at that maximum right there, and we can connect that, and this is just a little way of estimating things, and it is an estimate. Estimate, not an estimate. It's an estimate. It's an estimate. And there it is. Now, if you're thinking, whoa, you're off. Yeah, I'm off. It's an estimate. I am not. If I found this area right here under what I drew, which is basically a rectangle and a triangle, or you could call it two trapezoids, however you want to look at it, then I am not counting this little area. And I am counting this area. So notice this, and this is going to happen in the next lesson. We're going to start estimating areas, and I am counting stuff that I shouldn't be counting, and I'm not counting stuff that I should be counting, and just, this is the way I call it, eyeballing it. It looks like it's going to turn out about the same. I can't guarantee that it will be exactly the same. It's probably not, but it's going to be pretty close to what it should be. So let's just find this area. I'm going to treat it like green. I'm going to treat it like a rectangle and a triangle. A terrible triangle that's not meeting the way I want it to meet. And here's the height of that triangle. So let's do it. We're going to have a triangle plus a rectangle. All right, triangle. The triangle is 1/2 base times height. The base is 50. The height is not this entire height, which would be 90, okay? The height of the triangle itself, it goes from 30 to 90, which would be 60, okay? That is its height, 10, 20, 30, 40, 50, 60. The rectangle itself is 50 wide and 30 high. We'll pretend like our calculators are inactive, and we will proceed. So 30 is half of 60. I was going to take half of 50 and you get 25, which is doable, but half of 60 is 30. 30 times 50 is 1,500. And then that is also 1,500. And so in this, we have 3,000 cubic feet. There we go. Now, let's be real honest. Is that how many cubic feet of air there are in there? We don't know. They said estimate the number of cubic feet of air that was pumped into the balloon in the first 50 minutes. We don't know how inflated this balloon was to start with. Terrifying, I know, right? We don't know, but for 50 minutes that we can see in the graph, that's how much air we estimate went in.